Good morning, everyone, and welcome to the Esri UK webinar on creating and sharing actionable community risk intelligence for fire and rescue services. We'll give it just another few more seconds before we start the full webinar. Thank you. Good morning, everyone, and welcome to the Esri UK webinar on creating and sharing actionable community risk intelligence for fire and rescue services. So let's start quickly with some introductions. My name is Leanne Little. I'm a customer success manager working in the public safety team here at Esri UK. I'm delighted to be your host today and to be joined alongside my colleague David, who will now introduce himself.
Hey there, everyone. I'm also in the public safety team with Leanne, but I focus on the technical side, showcasing the possibilities, helping customers get up to speed. So you'll be getting a demo from me in a moment.
Great, thanks, Dave. So let's now move on to some housekeeping. The webinar will be recorded today, and a link to the recording alongside a briefing pack will be sent to all attendees shortly following the webinar. Today's webinar will include a short presentation, demo, as Dave just mentioned, as well as a question and answer session. The question and answer session will be using Slido. So you'll be able to get that up and running now. So you'll be able to do that by going to slido.com by typing it into a web browser or just scanning the QR code shown on screen. Then you'll be asked to submit a code, and the session for the Q&A session code is ESRI, all in lowercase, 1209. We do have a small ask that if you do submit a question throughout the webinar, that you also include your name and the service or organisation that you're from, because if we don't have time to answer your question during the session, we'll follow up with you directly after, or we may seek some clarity on your question before answering to make sure we give you the most accurate information. When you join Slido and the questions start appearing, you'll also be able to upvote other attendees' questions. So please do, as this helps us prioritise the questions to answer during the Q&A. In a short moment, I'm going to quickly turn off my camera, as will Dave, and we'll start the presentation and make sure the slides are in full view for you. So thank you for your attention so far. I hope you've managed to get Slido, and I hope you also look forward to the rest of the webinar. Okay, so let's start with some background to community risk. UK fire and rescue services play a vital role in community safety. All fire and rescue services carry out community risk management planning to identify and assess the foreseeable risks that could harm or threaten the safety of their local communities, businesses, the environment, and economy. This information is then used to make decisions on the location and deployment of resources, ensuring that the service provides an efficient and effective response to calls for service and incidents when needed. It is also used to deliver a wide range of prevention and protection activities, which aim to reduce or mitigate the risk from incidents occurring in the first place. From the development through to the implementation of community risk management plans, data and business intelligence is a key asset that is used and can be used also in fire and rescue services to help them understand the many different aspects of the risks faced by communities, provides an evidence base for decisions that are made as a result, enables monitoring of performance, and is also used for evaluation purposes. Data intelligence is also a key part in supporting collaborative cross-border, local, and national resilience work. Fire and rescue services collect and use a wide range of data and intelligence from internal, external, and third-party sources to use in community risk management planning. This data intelligence will likely have a location component or attribute, as everything happens somewhere. For example, A 999 caller will provide location information such as an address that will help the control operator to locate the caller and dispatch the nearest available appliance or officer. Data with a location attribute can also be linked to other geographic layers. For example, an address has a postcode, which is also linked to lower super output areas, ward, or even a fire service boundary. As a result, seemingly disparate datasets, perhaps stored in different systems or from other sources, can be linked together based on this location attribute. From a technological perspective, a geographic information system, or GIS for short, can help fire and rescue services bring together, layer and visualize your datasets. Spatial analysis tools within a GIS can help fire and rescue services identify hidden patterns and relationships, so new insights and intelligence can be found about the risks that are being faced by your local communities. Spatial analysis also complements other forms of analysis that fire and rescue service analysts will do as part of community risk management planning. GIS can also be used to share insights and intelligence with others, because maps and interactive dashboards which have these visuals tap into a visual storytelling language that we intuitively understand. This means community risk data, insights, and intelligence shared with a geographic context can help improve understanding and decision making within fire and rescue services, as well as enable collaboration and improve problem solving with partners. So today we are delighted to be able to showcase how some of the ArcGIS platform can support fire and rescue services with using their current data and future data sets that are required for risk analysis and assessment for day-to-day or community risk management planning. We'll cover off in 3 elements. We'll start with incident analysis, as this is a common activity carried out by most analysts within the services. We'll showcase some simple techniques to visualize and analyze incident data. Next, we'll go on into our ArcGIS Pro software, where we'll start to look at more robust spatial analysis, being able to use a wide of data sets and the advanced tools within this capability to model response time and demand. Of course, the results of such analysis and scenarios need to be shared with others, as mentioned previously. So we'll also showcase how Esri's simple web applications will enable those insights and intelligence to be shared with a wider community. I hope you're looking forward to the demo. I'll now hand over to my colleague, Dave.
Great, thanks, Leanne. Okay, so hopefully everyone is seeing my screen okay at the moment. As Leanne says, I'm going to run through a variety of demos to talk through some of the capabilities here, but it's worth talking about the data I'm going to use for this demo to start with. So this is some real data for Oxfordshire from a few years ago. I'm going to use this across the entire demo because it's pretty much all I've got available, because it was shared through a Freedom of Information request a few years ago. So it's a great data set. It is real, so hopefully I can showcase many of the possibilities through this data. Now, just to be clear, I haven't worked with Oxfordshire on this demo, so these are all my own ideas. So hopefully I've got plenty of good ideas, but it's not in associated with them specifically. The first thing I want to highlight is that the geographic approach is so much more available to all users than it's ever been. There's lots of tools for creating maps, and I want to show you a couple of examples of those that you'll have access to already, regardless of whether you're an Esri customer or not. So within this Excel environment, we can actually start creating maps. So there's a plugin for Excel that's available from the Microsoft Store called ArcGIS for Excel. And what this allows me to do is it brings in this new toolbar. I can click Show Map to add a map to the environment. And then from that, I can add in the Excel data I've got to this map. So it's a step-by-step process that's very easy to follow. So I've already got a table defined here, so it's picked that up. It's picked up those coordinates, so we're going to use the X and Y coordinates that are in the spreadsheet to create the geography. When I add that, it will process for a few seconds, and then it adds it very nicely into my display, so I can see the distribution of instance across the Oxfordshire area. Now, if I progress across these tabs, I can start to update the way this data is displayed. So at the moment, we're seeing all points symbolized in the same way, but it might be that I want to change that symbology based on the type of callout. So I can add a field, and I'm going to look to change the color based on the final result. So this is now color coding all of those symbols based on, is it a primary fire, is it a false alarm, is it co-responder? So it just gives me a little bit more intelligence. On the next tab, I can see the color scheme that's been chosen for those, and I can update if I so wish. But more interestingly, I've also got the option to turn on clustering, because at the moment, I can see the distribution of points, but it's very difficult to tell, well, where is most of the activity taking place. But by turning on clustering, it's now grouping that together into smaller areas where I can see where the majority of incidents are taking place. And if I reduce the radius slightly, I get a little bit more clarity. So quickly and easily, we've created a map here that helps me understand the distribution of incidents across Oxfordshire. I can see where the hotspots are, and I can see what the dominant response type is in each location. And as I zoom in, I get more and more detail to pull out as I need. So hopefully you'll appreciate this is a really nice tool, very simple and easy to get up and running with, and it's in Excel, an environment many of you will be using every day. To follow that theme, I also want to talk about Power BI, because this again is a tool that's used by a lot of emergency services. And so I've started creating a dashboard here. So I've got a few graph elements that you'd expect to see. But over here on the right, under the visualizations, there's an option at the bottom called ArcGIS Maps for Power BI. So this is available to you now. You don't need to do any additional install. It's just part of the Power BI environment. When I click that, it's going to add a new card. I can expand that to make it a little bit bigger. And I can sign in, but I'm going to continue as guest because I want to show you what is available out of the box without needing to be an Esri customer. And I now want to start adding data to this display. So this is the same Oxfordshire data that we've just been looking at in Excel. I've got the X and Y here, and I just drag those into the options here. So we can now visualize the locations of the instance, and it's going to zoom me down. And then as before, I could use the final result as a way of displaying different colors. Once I've done that, I get a very similar experience to the Excel environment where I can run through these various different tabs to see the different ways I want to display the data. So it might be that I want to change the symbol type, or it might be that I want to turn on clustering. Now, the nice thing about the Power BI environment is that it will interact with the rest of your charts and graphs. So, if I wanted to look at, well, where all the primary fires taking place, I can choose that in my graph, and that will update the display just to show those incident types. And as before, if I zoom in, I get more and more detail. So there's a couple of really nice examples there where you can start creating visualizations of your data in environments you're already using. What I want to do for the rest of the session is show you how ArcGIS perhaps takes this up to the next level, and we can do more detailed analysis and start sharing and collaborating with the rest of our service. So to start with, I'm going to be using ArcGIS Pro. So this is our desktop environment where analysts would do the majority of their work. So this provides a really nice interface for bringing data together, visualizing it, and running complex analytical workflows. So to start with, I've just got a map. I haven't added any data in because I want to start showing you the process of adding data, visualizing it, doing the analysis. So to start with, I need to add that spreadsheet. So I'm going to use the XY table to point tool, which allows me to point at a spreadsheet, and I can create a new geographic data set from that. So we'll call this instance, and it's picked up the X and Y as we've shown on the other applications. I can run that, and that's actually going to create a geographic data set for me in my local database, so I can start working with it in this environment. As before, it's given me some default symbology where I can see the distribution of instance, and if I click on any of these, it brings me back all of that really great information that was included in the spreadsheet. Or I can right click and open up the attribute table if I want to see all of that information. Once we have it in the display, we can start thinking about different visual techniques that might help us better understand the data. And certainly when I'm got a data set for the first time, I don't immediately jump towards the analytical tools. I think about different visualization techniques that help me understand the data that perhaps informs the analytical approach I'm going to take further down the line. So to show you that, I'm going to copy this data set a couple of times so I can show you different visualization techniques. And the first one I want to show you is clustering. I touched on that in the two Microsoft demos, and I just want to give you the same experience in the ArcGIS environment. So if I go to my symbology tab here, I can update the way this data is displayed. At the moment, it's just a single symbol, but I've got different ways of presenting that. So if I chose unique values, and then I choose the final result, it's then going to give me some symbols that define the different response types. I've got a variety of different color schemes I can choose from. So I quite like the enamel one just because it's got a good range of colors, but I can go in and manually change any of these if I so wish. So if you've got certain corporate color schemes that you need to maintain, then it's all entirely configurable. Now, as before, when I've done this, we can see the different instance types, and as we zoom in, we can start picking out where those hotspot locations are. But it is quite nice to be able to visualize this in a slightly different way. So if I go up to my feature layer option here, we've got some dynamic aggregation options. One of those is clustering. And then once I've turned on clustering, it might be that I want to configure the way that clustering operates. So I can go to my clustering options here, where I can choose how much tolerance do I want on the clustering, and what size do I want each of the symbols to be. So I personally think 70 is a little bit big, so perhaps drop that down to 40 so that there's less definition between the bigger clusters and the smaller. So very quick, very easy to start visualizing this data. Another option is to create a hotspot map. So if we rename this, again, I can go to my symbology options here, and I can choose to create a heat map. Now there's a couple of configurations options here. I'm going to choose to have dynamic heat map, which means as I zoom in, it's going to recalculate the heat map so I get better definition as I zoom in at various different scales. And I'm going to reduce the radius slightly so I get more detail to the hotspots. So we can now start picking out those key locations, and as we zoom in, we're going to get more and more clarity because that heat map will re-render to pick out the key locations. So both those techniques, heat maps and clustering, are good ways of better understanding your data before you start doing any analysis at all. What I want to show you now, though, is how we can start doing a little bit of analysis to pick out key locations that might be important for response efforts. So to do that, I want to pick out the top 10 locations across Oxfordshire for primary fire response. So to do that, I'm going to first add a grid data set. So you can see that I've got a variety of different databases here. For my demo, I've just got a few data sets. We could drag in this grid. Now, I really like grids because they have a uniform size, and when we visualize data against it is very easy to interpret, but you could use neighborhoods, postcodes, LSWAs, whatever geography you personally think is of most use. And what I want to do is I want to join these points to my grid and then visualize based on the count. Now, for those of you that have been using ArcGIS for a while, you might initially think that that is the spatial join tool. But what I want to do is show you a slightly different approach. So if I search in my geoprocessing tab for summarize, there's a tool called summarize instant count. And if I run that, then I'll talk about why this is so much better than spatial join. So my input features are going to be the grid. My summary features are going to be the instant data. We're going to create a new data set called instant count. And this is where the difference is I'm going to choose a group field, which is going to be my final result. And I'll start that running. While that's processing, what this is doing is it's creating a count of all instants for each grid square, but also it's breaking that down by instant type. So we'll be able to see how many primary fires, how many false alarms, how many malicious false alarms. It's going to give us a complete breakdown area by area. So it does give us some really nice additional visualization capabilities, and it means you can present the data in slightly different ways. So that should be finished fairly shortly, and it will add it to my map, and we can now see the distribution of instance across Oxfordshire. And when I click on any one of these, you'll see that yes, we do have a total count here at the bottom, which is what's being used for visualization at the moment, but we can see a breakdown of all the other instant types that we've responded to in that particular area. So for our case study here of looking at primary fire, I can change the visualization from total count to primary fire, and it's going to update that visualization. Then what I can do is I can open up the attribute table, perhaps order my data by the primary fire count, and we can see if we look at the top 10, it's anything 12 and above. What I can then do is I can go into my properties of my data layer, and I can create a definition query. What this is it's just filtering the data down so you're just seeing what's most interesting. So I'm going to say that I want to only show the data where primary fire is greater than or equal to 12. And that's filtering down the data to just the top 10 locations where we're seeing most primary fire incidents take place. So it's a really nice way of visualizing the data, understanding where your hotspots are, and then providing a lot of clarity on those key locations. And if there's anyone here from the police community as well, this is the way that hotspot patrols can be defined to gain home office funding. So very similar approach for looking at, well, where are our key locations. So hopefully that's given you a flavor, a fairly simple start to how we can start visualizing instant data. But while we're still looking at instance, I want to talk about community risk, because the NFCC provided a methodology recently for defining risk across your communities. And I just wanted to reassure you that that process can be replicated in ArcGIS so that you can produce either the LSOA breakdown, as I'm showing here, where we've got risk categories which break it down by consequence and likelihood. But we can also do the UPRN focused analysis if that's providing you a little bit more detail. As ever, the whole thing's flexible, so if there are other data sets you think are important to apply to this process, then you can start adding those in yourself. Now, as part of this presentation, we've got a fairly mixed audience, so there'll be some analysts, there'll be some senior officers here. I want to talk through both the analytical approach and how you can share that with a much wider community. So if you're an analyst and you've done some great work here, reducing the risk cover across your community, when you brief an officer, you're probably not going to use Pro as that environment. you might use slides, you might use PDFs, but a different approach would be to create a dynamic dashboard. So this is using our web tools where we can share our data from desktop into the online environment and create simple apps that allow us to engage with this data in a slightly different way. So this map is dynamic, so we can pan, we can zoom, we can look at the data in any way we wish. But I've also included some simple dashboard elements so we can see the breakdown of risk across Oxfordshire. So if I look at very high, we can see, well, these are the areas where we're seeing very high risk in our communities. If there's one particular location that's particularly important, so I've ordered the areas by their score here, and we can see that this location in Cherwell comes out top. If I click on that, it will zoom me down to that location, and I've set a slight transparency against the data so we can see a little bit of the geography behind the scenes. So these sort of dashboards are a really nice way of sharing this information with a much wider community in a way that they can engage and interact with, so they ideally can brief themselves on the great work that you've done as an analyst. So we'll keep coming back to these sort of ideas as we go through the demo. Before we finish with the pro stuff though, I want to briefly talk you through some work I've done recently on cover and demand modeling. So if I quickly talk through the data here, so I've got fire stations across Oxfordshire and I've color coded them based on the type. So we've got whole time, day, and on call. Now, when the data that I'm using was first available, there was less fire stations than there are currently. So those of you might notice that I'm missing a fire station. That's deliberate because I'm showing the fire stations that were available at the time that the data was published. I've got some potential new fire station locations. I've got the instant data that we've shown before. I've also got an underlying routing data set. So most of you would probably get this from Ordnance Survey, so the new transport layer. So if processed and made available to Esri, we can use that as an underlying network data set for doing analysis around service areas, demand, and cover modeling. So I just want to talk you through some of the analysis I've done. So first up, in Oxfordshire, their target response time is 14 minutes. Now, if I take 3 minutes for the call handling and rollout, that means I've got 11 minutes left for actual drive time. So this is showing 11-minute drive times around each of those fire stations. And it might be that I then want to cross-reference that against other data sets, such as points of interest. So this is where I've picked out various key bits of infrastructure. So this is an Ordnance Survey data set, which is really useful for understanding the infrastructure in your communities. And I can see here visually the locations of all of my POI, but it might be I want to analyze that to think, okay, well, which of those POI do not fall within my response times? And then I can open up the attribute table and review. So in this case, there's 25 locations that aren't currently covered. I can see here that a lot of these are primary schools. So it might be that I want to look at mitigation measures to understand how can we respond effectively to those locations in the worst case scenario. What I've also done is bring in the IMD deprivation data. So this is from Office of National Statistics. And again, I can visually see my communities in relation to my service areas, but it might be I want to look at just those communities that are a little bit more deprived than the rest. And the good news here is that all these deprived communities are very well covered by the existing service areas. Next up, I created service areas 1 minute at a time, because what I want to understand is if I look at all the properties across Oxfordshire, can I understand how quickly can I respond? So get a breakdown property by property. So by looking at these 1 minute service areas, I can then join that to my addresses. And I can create an attribute table that then gives me that breakdown. So in this example, we can see that only a very small, I think it's about 4% of all addresses across Oxfordshire are not covered within that 14-minute response time, and 60% are covered within 5 minutes. So a really good way of looking at the response times across your entire community. Next up, I was interested in looking at demand. So what we can do is we can take the incident data and associate it with the fire station that's most likely to respond. So then we can see, well, what is the demand against all of our facilities? And if I open up the attribute table here, we can see, most call outs are coming to the city stations like Slade Park and Rewley Road. They have a lot of activity throughout the year. But we can also see that some of the more rural stations, such as on-call stations in Hook Norton and Charlbury, see very few incidents across the year, which is exactly why they're on call. So demand modeling is a really good way of looking at the impact on your stations. Now, this is obviously using historic data, but I could play this forward and look at how perhaps a loss of a station or the introduction of a new station might affect demand across our community. What I can also do is I can use various different algorithms to look at what are the different ways of managing my network. So in this example, I've applied the same methodology to demand management, but I said, in light of the fact that I want to get everywhere within 14 minutes, can I minimize my facilities? Are there any fire stations that aren't required? And what this is showing, you're probably noticing there's no difference here, and that's exactly the outcome. This analysis has shown that there is no possibility of reducing the number of stations because they're all required to support that 14-minute response time across this area. Now, I've shown you kind of the as-is situation where all stations are available. It's also possible to run this same process against other scenarios. So maybe Abingdon's not available. What's the impact on our response and service areas if that's the case? What if we introduce a new station? How is that going to affect everything? So I'm going to mention those in a moment. But again, this is the analytical approach. When it comes to sharing that with your community, could we create something a little bit more like this? So this is a story map which allows me to take the analytical work I've done and explain it clearly with the community that I want to share it with. So this might be your senior officers, or it might be you're sharing some information with the public that details the work you're doing in the community. So as I scroll down, it talks through the narrative, but I can include graphs, charts, maps, videos, audio to really make that story come alive. So this information comes from NFCC about turnout and call handling times. Then I can start looking at the focus of my scenario. Now I've covered the current service areas. So if we just jump to Abingdon being unavailable, we can run through this where it's going to show me, okay, well, if Abingdon's not available, it does leave a significant gap down to the south of Oxford. And then I can see, okay, well, how does that affect my response times and my ability to support the community? So we can see that the number of addresses that are now outside our standard response time has massively increased. So then we can look at different scenarios about, well, how could we resolve that? So one option would be to ask the stations in that same area to perhaps drive slightly further with a slightly longer response time. So if we push that out to, rather than the 11-minute drive, to a 14-minute drive, we can actually see that covers the area quite nicely. I can see that drops down the number of people that are outside that response time. And I can also model the impact on those stations. So if Abingdon wasn't available, then Didcot and Slade Park are going to take on the majority of that extra demand, and I can get a feel for, well, how much demand are they likely to see across the year. Now, obviously, in a normal scenario, you're hoping a fire station is not going to be unavailable for a whole year, but it might be it's temporarily unavailable because of sickness or infrastructure changes. So this allows you to model those scenarios to better understand, well, how can we respond, how can we protect our community, and what's the impact across the rest of our network. So please do consider story maps if you want to provide a more narrative-driven approach. What I want to talk about now, though, is the other sort of web applications that allow you to share information with your community. And the first thing I want to talk about is the value of thinking about the team you're trying to support. So for the next three examples, I'm going to be using exactly the same data. In fact, I'm just presenting it slightly differently depending on the community I'm targeting. So if I wanted to provide information to officers about the fire demand in their area, this is a very simple web application that allows people to just interrogate the data that's of interest to them. So I can zoom, I can pan, I can see detail about the map, though that's frozen, so we might need to come back to that. Okay, we're back. So yeah, I can zoom, I can pan, I can see the distribution of instance. I've got a little bit of layer control, so I could turn on the instance and turn on the instant count. So this is showing those hotspot areas that we pulled out earlier. I've also provided some very simple filtering tools. So if I just want to look at primary fire, I can pick those out as well. So simple application, doesn't require any training, but allows an analyst to share this data with the wider community so they can start working with it and briefing themselves. Now, if I was to share this same data with a more senior officer, they might want a slightly different view. They might be more interested in the metrics. So how many incident callouts have we had this month, this week, this day? What is the general trend over time? What's the breakdown of incidents by type? And so this dashboard is servicing that community. Same data, just presented in a slightly different way. So I've got a breakdown of incident types, and these graphs and charts will interact with the map. So if I want to look at just primary fire, I can select that and it will update the map to show just those. The other elements will also update, so I can see that we've had 69 primary fire incidents in this month. I can also see a breakdown of the temporal changes, so changes during the week, changes during the day, and over the course of this month. So really nice ways of visualizing the data so that a senior officer can just understand exactly what's happening across the service. What about if you wanted to provide a more focused view for an individual station? So all credit to Humberside, I took inspiration from some of the great work they've been doing for this particular story map. So the idea is to try and create a profile on an individual station, and that might include a demographic breakdown of the community that they support. And then we can start bringing in interactive graphs and charts that help them understand, okay, well, this is a breakdown of incident types across its area. So if I wanted to look at property fires, then I can select that and my dashboard will update. So simple ways of interacting with the data. I've also got another chart that looks at the seasonal profile. Again, this might give them key intelligence. So, when it's Guy Fawkes night, where are we seeing most activities? Are there certain communities that are perhaps more likely to need our support during the winter? And this is a good example of that. When I filter to January, the profile of instance is very geographically constrained. So this is the Bird Hill estate. So what is happening in January in that community and how can we help them? Finally, at the bottom here, I've got a deprivation profile. So I've included the IMD data that I discussed earlier, but again, allow me to interact with this. So if I want to look at, well, where are the communities that perhaps most needed my support, I can see those on the map. And these might make great locations for home safety visits to support those people. Now, over the course of this presentation, I've talked a lot about incidents because I've got a really good incident data set to work with. But I just, in this final example, want to explain that it doesn't always have to be fire incident data. It could be any other data set you've got, which has got a geographic component you can share with your community in a way that they can engage with. So this is using Department for Transport data around traffic collisions, where I've just looked at the breakdown of incident types across Surrey. So very similar to that earlier fire dashboard I showed, but I've got lots of different parameters that I can use to filter my data. So I can see the general distribution of collisions across Surrey, but if I wanted to, I could look at, okay, well, what about wet weather collisions? So where are we seeing accidents that are taking place under those wet weather conditions? So by filtering that, the display will update, as will the rest of the graphs. Funnily enough, lots of the weather happens during the winter. November in particular seems to be quite important. So that breaks it down to several key locations where we're struggling with collisions in November. So perhaps we can target those specific junctions to work out, okay, well, why are we seeing such issues in those locations and what can we do to make them safer? So dashboards are a great way of showing that information out to that community so they can interact and make their own decisions against it. So that's pretty much me for the demo. Hopefully you found that really useful. Just as a recap on what I've covered, we started talking about incident analysis, and I touched on a couple of Microsoft tools that allow you to start digging into the data with existing tool sets you already have. So Excel, Power BI, great introductory tools for geographic analysis. Before we moved on to Pro, which provides us a lot more capability. Now, we've only really scratched the surface today. There's so much more we could do. So if you're interested, please do reach out. I then looked at cover and demand modeling, showing how we can use an underlying road network dataset to look at, well, what is the cover like across our community? Are there any gaps and how can we mitigate them? And then we finished off with simple web applications for sharing your information with your community. That could be internally, it could be with the public, it could be with your partners. So if you're working on resilience projects, then web applications are a really great way of everybody involved with that project collaborating together so that you can see the status of flood evacuation or emergency response that can be shared with all the partners for that particular project. So with that, I'm going to hand over to Leanne very quickly, who's going to wrap up. Over to you, Leanne. Leanne, I'm not hearing you if you're talking at the moment.
Hello? Can you hear me, Dave?
Yes, that's good.
Great, thanks guys. Sorry about that. Forgot to unmute standard. So we're now going to switch across onto the question and answer session following Dave's fantastic demo. For those who might have joined a little bit later, I've just popped on the screen the instructions to how to load Slido and the appropriate code to access today's session, which is ESRI, all in lowercase, 1209. Thank you to those who've already submitted some questions and upvoted others. Be fantastic. I'd just like to remind you before we quickly step across into that is that we will be sharing this recording of the webinar and a briefing pack shortly following. So do check for your inbox and perhaps check your junk folder if you've not received anything by Monday. If you do want to get in touch about any of the sort of capabilities, products and applications that we've shown today, please do get in touch with a point of contact at that email and we'll be able to follow up with you with that as well. So without further ado, Dave, should we step across into Slido and start answering everyone's brilliant questions?
Okay, I will do. Let me share again. Okay, so hopefully everyone can see that as well. So let's just start running through some of these questions and we'll take them off as we go through. So the first one at the moment is the ArcGIS plugin for Excel free. Yes, it is. So it's freely available to download and install from the Microsoft Store. I showed you the guest version today, so I hadn't logged into ArcGIS Online. If you did have an ArcGIS Online account, so once you become a customer with us, then it opens up a little bit more capability. So for one, it allows you to publish to our web environment. So you can create a map in Excel, publish it to the web, and then start creating some really nice engaging applications. Next up, another ArcGIS for Excel question. So Kelly asks, can it accept eastings and northings? So as far as I'm aware, it uses a global coordinate system only at the moment. It can, however, use addresses. And if you've got data that is using British National Coordinates, then my recommendation would be to use Pro, because that can support any coordinate system across the planet. So certainly if you're looking for things along those lines, then Pro might be the better place. Can story maps be shared? Yes, absolutely. So we haven't touched on it today, but whenever you create a application, whether it be a story map or any of the others, you get a lot of choices around who you're going to share it with. So by default, when you create an application, it's not shared with anyone. It's only available to you, the creator. Once you finish building it, you can then decide, okay, who do I want to share it with? So do I want to share it with just my organization? So that means anyone who's got a login to your account can access it. Do you want to share it with the public? And obviously be mindful, of what you're sharing. Make sure you're only sharing the information that you're happy to go publicly, but that is an option. So if you created a story map about the engagement you've had with the community, you could absolutely share that as a public story map. No one would need to log in. You can just put that on your website and people can engage and interact with it. The final option is, do you want to share it with a project group? So a specific group of users that you define. So it might be you're working on a vulnerability program and you want to make sure that that data is kept very securely to a very small number of users. So in that case, you'd share via a group and you would choose who is in that group. So there's lots of fine-grained control over who sees what, and you are always in absolute control. And while we're talking about that, it's worth saying that Esri doesn't have access to any of this either. So, we've got no access to any of your content at all. So it really is constrained entirely to you and your users. Next up is the Excel plugin. If you're using it, is any data stored anywhere beyond the private Microsoft Cloud? So if you're using the Excel plugin, it will only stay on your laptop. So it's not shared anywhere unless you decide to do so. So if you create a nice map in Excel, save it to your local drive, then it doesn't go any further. If you decide, actually, I want to share that to my ArcGIS environment, then it would go up to the cloud environment that, again, you control, and then you can decide who sees it and who can interact with it. With Power BI, so Power BI will load it into the Power BI environment, and it then sits in the Power BI environment until you decide, well, where are you going to share it. So typically you'd share with your community, so everyone who's got a login to Power BI will be able to see it, but again, you can share it more broadly if you so wish. Will I be showing my demo files and a story map? So that's a good question, and I'm going to do a little bit of blatant promotion because I've actually been working on this recently. It's not finished, but I'm happy to share this in the follow-up email. But I recognize that some of the time, getting used to Pro just requires a little bit of support, and that's why I'm here. But so that I can provide some materials for the community to get running as quickly as possible, I've started building this website. So it's Public Safety Learning Hub Esri UK. And in here, I've got details of upcoming webinars that people might find useful. I've got some tutorials on how to get up and running with Pro. And the bit that's not finished is I'm hoping to add a few videos in this section where I'm going to run through the basic tasks as I've just done on this webinar. So there'll be a whole video series that will touch on many of the common workflows across public safety. I've also included demo galleries. So there's a police demo gallery and a fire demo gallery, which hopefully give you a little bit of inspiration to perhaps create applications yourself. And all of these are public. So if you want to use any of these applications or any of these data sets yourselves, then they are all available publicly if you want to start playing with them. I'm also at some point going to start sharing some Pro projects that include open data so that people can run through some of the common tasks that I've just covered. So keep an eye on this. Hopefully it will be updated soon, but it's going to grow over time as we get more and more collateral prepared. And then finally, can you select and deselect which incident types are displayed? Yes, so if you're in the pro environment, then you can do a definition query. So if you remember, I did a definition query to say I only wanted to see the top 10 locations for primary fires. I could use a definition query to filter any of my data set. So if I wanted to just look at all the instance, but just show primary fire, I could do so. If I wanted to look at traffic accidents that happened in the rain, I could do so. So within Pro, you can use definition queries. Within the web applications, you can use filters or interactive elements of your dashboard. So there's lots of different ways of filtering the data to see just what you're interested in. And that, I think, is the last of the questions. So hopefully that's been useful. It's good to have so many of you involved in the webinar today. As Leanne said, we are going to share as much information as we can in follow-up emails. If you've got further questions that you didn't have time to post today, then please do reach out. Thanks very much for being here. Look forward to catching up with you in further meetings. Thanks, everybody.
Thank you, everyone.